Alright, in this video we're going to be talking about how to find the derivative of function of x equals e to the power of the quantity of x squared plus 3x squared. Now before we get into this, let's talk about the two main concepts we're going to use. We have the derivative of e to the power of x and the chain rule. Both of these we're going to use to get this derivative. So the first step is to take this top quantity right here, e plus 3x to the squared, and simplify that out. That'll decrease the amount of times we need to use the chain rule. So for this, we're just going to multiply that out. Which ends up, of course, giving us x. X to the fourth plus 6x cubed plus 9x squared. So now we rewrite the equation as f of x equals e to the power of x cubed plus 6, x to the fourth plus 6x cubed plus 9x squared. Okay, so first thing we're going to do is we know that the derivative of e to the x equals e to the x. So what we want to do is we want to convert this into something like that. For this, we're going to use something called the chain rule. Basically, we are going to represent this top section of the equation with the letter u. So u will equal x to the fourth plus 6x cubed plus 9x squared. Okay? So now instead of having this, we have e to the u, which obviously looks like e to the x. So we know that the derivative would be e to the u. However, the one thing you have to keep in mind when using the chain rule is basically you take the derivative of this parent function and multiply it, the derivative of the parent function in respect to x, and multiply it by the derivative of the smaller equation in respect to the larger equation. So now we have e to the u, but we also have to multiply that by the derivative of u, which we can solve over here, and this is a pretty simple derivative. It would just be 4x cubed plus 18x squared plus 18x. So obviously now this is our derivative, which would give us, and we just substitute u and du, and then multiply it by du, which will be this right here. We're starting to overflow, so I'll kind of come down a little bit. However, there's one more step. Because of this, because of the fact that we're finding d over dx, or just the derivative, we have to have dx on both sides. We're not actually multiplying it out. So our final answer, so the derivative of f of x would end up equaling e to the power of the quantity x to the fourth plus 6x cubed plus 9x squared times 4x cubed plus 18x squared plus 18x, and that entire quantity multiplied by d of x. Let's go over some things. We can see here how we used the derivative of e of x to find the derivative of e to the u. And we actually could have written this here. You see, that's where we're kind of making that decision here. But we also use the concepts of the chain rule with u equaling this and d equaling this. And the reason we do this is simply because this is pretty complex in and of itself, and so it makes more sense to break it down to its simpler parts and take the derivative of that, rather than trying to take the derivative of this entire function. And of course, once we get that done, we can just go and multiply by the derivative of u and the derivative of x, and we end up getting our full answer. Now, you'll notice that I simplified the x squared plus 3x squared. That is not actually necessary. If you wanted, you could do more layers, the chain rule, and then break that down further. So for example, you could have u equals x squared plus 3x, and then have u squared, and then just keep going further down and end up with what we had. But the result is the same, and it just depends on whether or not you want to add an extra step in the beginning or towards the middle. So as you can see, we got our result, and that is all for this problem.